There it is, the Sea of Tranquility. And here's my workbench. Greetings, Earthlings. Well, as you can see, I have moved, and I'm still getting settled into my new place here, but I have had a little time to go back and look at the Nova 445, play with it a little bit. So what we're looking at today is an attempt to output characters using the serial port. If you'll recall, when I made the second revision of the video card, what was originally the video card, I added a sound chip and a serial port. And so the video is working. We verified that in the last video, I think. So I've moved on to the serial port, and we've got some issues here. As you'll see, what I've got it hooked up to this terminal. This is a Texas Instruments Silence 700, which runs at 300 baud. So I've got the serial port connected to that, and I just have a simple test program. I modified the existing program so that it will output something to the graphics screen, just so that I know that it's getting that far. And then it attempts to output characters to the terminal, hello world, or whatever. But as we will see, whoops, there goes my little red pointer. Okay. As we'll see, well, you're not going to see it because the terminal is out of the screen, but this is just, oh, look, red pointer. This is just showing the 5 volts when it hits the board. Got this issue still. But here's the terminal. And as you can see, it's apparently not doing anything. So the test code is very simple. Nova I/O is done through I/O instructions, and there is a busy flag and a done flag for each device. Busy gets set when you tell it to do something. Done gets set when the operation is completed, and setting done should clear busy. So the code is in a tight loop, skipping if busy is 0, so waiting to see if it's free to send a character to the terminal. And it's getting stuck in that loop. And as we see over here on the scope, what we're seeing here is the busy signal. So there's ground down there somewhere. We can see that busy is constantly on. And if I reset and start again from 0, we can see that initially busy starts at 0. It then does go to 1. So it apparently tries to send a single character to the terminal, but that character is a non-printing character, apparently. I don't know. And we never actually get busy going back to 0. Oh, wrong. This one. There's nothing there. There's no case where it goes to 0. You can see maybe it's trying. That's what these little glitches are. But it never actually goes to 0. So what's going on? Well, if that stuff hadn't fallen on the floor, I could tell you. We'll look here at the circuit. Don't know if you can see that very well. This is the busy right here. Right there is the busy. Whoops. I say right there is the busy flip-flop. And it gets set asynchronously on a I don't know if you can see that, a start a start that goes to the TTO device. So I've got these connected here to start and let me see. Okay, the blue trace is start, and that's inverted, and the red trace is the skip. So I'm doing a skip if busy is 0. Okay, and let's run that again. See what we're seeing. Okay. Okay, there you go. That's better. There. So what we can see is, what were those signals again? Blue is start and red is skip. So every time we issue a skip command, it thinks it's getting a start command as well. Well, what's up with that? What's up with that, you say? Okay. The decoding of the start signal is just, I'm using it as 74LS or F probably, F138 decoder, and it's looking at bits 8 and 9 of the I/O instruction. Now, so as it turns out, the busy 0 condition is the same as the start condition, which would be a 0, 1 in those bits, 8 and 9. The processor has no reason to put the skip condition out onto the bus, and so I foolishly assumed that it didn't, but it is. So I'm decoding that busy 0 condition as a start, and that would appear to be the problem. So there's a fix for that, which involves an AND gate or two to force it to 0. I don't know if you're going to be able to see that. Down there at the bottom. Skip is all ones of these lines, 5, 6, and 7. Bits 5, 6, and 7 of the instruction. All 1 indicates a skip. So the NAND gate that you see there, whoops, maybe you see there, the output of that will be 1 unless it's a skip. And if it's a skip, it will be 0. And so then that goes through another AND gate, which will feed one of the enable, which will feed one of the enable lines on this. Can I do that? Can I do that? Sure, why not? I don't know if that's in focus. Feed one of the enable lines on this chip. So if the enable, if it's not enabled, then all of the outputs will be set to 1. And so we won't get any of the start, clear, or pulse decodes on a skip. Okay. And that hopefully will resolve the problem. So that does require mods. Now this decoding is done on the main processor board. The other schematic I showed you of the serial port, that's actually on the second board, which I have been calling the graphics board, but is now what did I call it last time? The human computer interface board or something like that. So I've got the green is the main board, the blue is the graphics card. I've got to make some additional mods on the green board. The green board does have some mods already done. I don't know if you saw that on here, but there's that AND gate. That AND gate that got added and changed. That signal right there. You see that? You see that X? That is a decode for X. So this already has some blue wires. I have not made a second revision of the processor board yet, and that's a good thing because I'm about to make some more changes to it. So I guess I'll do that, and we'll come back when I have those changes in place and see if it fixes the problem. Okay, and I'm back. And here's what this board now looks like. I can turn this light off. See if you can see those. All the little blue wires. Some of them were already there, but I've added quite a few. So we'll plug this together and see what happens. Okay, so here we are. I've got it all plugged back together, and we'll fire it up and see what happens. I should bring this over into the screen so you can see if it actually does anything. That did not start properly. There we go. Okay. Now give it a couple of seconds and it should, there we go. Okay, it printed something. It printed EHLL. Okay, we've got a byte ordering problem here. It's trying to say hello world, but it's EHLL space OWLR. And there's a D missing. Oh, because it's picking up the null terminator. Okay, so it's the byte ordering is wrong because those are packed in a word, 2 bytes packed in a word, but it is printing. So we fixed the hardware problem, and now we have to deal with the software. But that's the easy part.